Okay, so have you done ratios before, Richard? Have you seen those before?
Might have done. I'm not sure though.
Okay.
I think sorry, just to interrupt because I heard you mentioning ratio. I think they have done some
Yeah.
very simple ratios, obviously, and I think it was a wee while ago now, wasn't it? Yeah, it wasn't recently. I don't think they've been doing any yet in year 6, as far as I'm aware.
Okay.
So it's going to be a few months at least, I think, before since he's done any.
Okay.
Okay.
We'll start easy and go from there.
Yeah. Okay. Right.
Okay. So so this one here, if you have the ratio of yellow is to red, for this one it would be 4:1. What would be the ratio for the second one?
It would be 2:1.
Well done. Is 2:1 the same as 1:2?
Yeah. Well, no. No.
Yeah, that would mean 1 yellow and 2 red. Yeah.
It would be different.
Yeah. What ratio is this?
There's 6 yellows
Right.
and 3 reds.
And so, could you make that simpler? 3:6? Or what if it was a fraction? 3/6.
Yeah.
Is there a times table both numbers are in?
Yeah, the 3 times table.
And so you can divide them both by 3. What would you get?
Well, 6 divided by 3 is 3.
No. 6 divided by 3?
Wait, no, sorry. No, it's actually 2.
Yeah.
And 3 divided by 3 is 1.
Well done. So just like with fractions, 3/6 is the same as 1/2, a half, and 3:6 is the same as 1:2. Exactly the same idea. So that means for every 3 reds there are 6 yellows, or more simply, for every 1 red there's 2 yellows. 1 red, 2 yellow, 1 red, 2 yellow, whichever way you want to look at it. Okay, read this question and try it.
So, to make 1 pot of pink paint, you mix 1 tube of red paint with 3 tubes of white paint. If you use 12 tubes of white paint, how many tubes of red paint will you need to make pink?
So it's red and white.
Yeah.
So how many red, how many white?
To make a single pot of pink paint, you need 1 tube of red paint and 3 tubes of white paint.
Okay. They say if you use 12 tubes of white, so that would be if you use 12 tubes of white, how many tubes of red would you need? How would you do that?
Well, Well, 3 take away 2 is 1. And
So, remember in the previous one, we divided them both by 3.
yeah.
In this case, what would you have to do to go from 3 to 12?
Well, you have to times it by 4.
That's it. And so you times them both by 4.
Okay.
And so this one?
Well, 1 times 4 is 4.
That's it. And so how many tubes of red paint do you need?
4.
Well done. 4 tubes of red. Well done. Any questions there?
No, don't have any.
Okay, so yeah, you could see that you divide 12 by 3 and you get 4, and so they must have times it by 4. So they were making 4 tubes in total. Okay, let's try these.
Shall I read it out?
Yeah.
Okay. In a class of 30 children, 18 are girls and 12 are boys. What is the ratio of girls to boys? Remember to simplify your answer. And then it says, simplify the ratio 100 to 75.
So we'll just do question 1. What would that be?
Well, for the first question, it's asking me for the ratio of girls to boys, so it would be 18 to 12.
And they say write your answer in its simplest form.
Okay. Well, I guess I'll need to find a times table that they are both in. And so they are both in the 6 times table. They're also both in the 1 times table, but that wouldn't be any good. And they are also in the 2 times table, but like with last week, we want to go over the biggest times table they both go in.
Correct.
So we would divide them both by 6.
What would you get?
But 18 divided by 6 is 3. And 12 divided by 6 is 2.
Well done. 3 is to 2. Yeah, I think you're good for that. And you could have done the smallest one. Okay, write the ratio below in each diagram. Let's do the second one.
Okay. Well, 7 of the boxes in that bar are shaded grey, and 3 of the boxes are white, so it's 7 to 3.
Well done. Let's do B.
Okay. So for B, it's asking me to colour the squares to make each ratio correct. For number B, it says 4 coloured and 2 white. So I would need to colour 4 of the bars.
Yeah.
And it says 2 white.
Yeah. And so I leave 2 white, and then?
And then
what I would do is do 4 more coloured.
oh, okay.
And 2 more white. And then?
You would colour in 4 more.
And does that leave 2 white at the end?
Yes.
Yes, so we know it's correct. Okay. Let's try this one.
Okay. When making cordial, Padma needs to add 4 measures of water for every 1 measure of cordial. What is this as a ratio? I think the ratio might be 4 to 1.
That's correct. That's all it is. 4 to 1. Okay, maybe. Okay, let's do this one.
Okay. To make mer
Meringue.
meringue, okay. Rosie whisked 160 grams of egg white with 240 grams of sugar. What was the ratio of egg white to sugar? Write the ratio in its simplest form. The ratio at first would be 160 to 240.
And because the numbers are so big, it'd probably be very difficult to find the biggest times table. So let's just start by finding any times table that will work.
Well, they both end in zeros, so they must both be in the 10 times table.
So that's a very good one to start with.
Yes. Since they also both end in zeros, they must also be in the 5 times table.
And so the 10 is bigger, so let's go with that one. And it's also easier.
Yeah. So 160 divided by 10 would be 16.
And the quick way of dividing by 10 is to just take off the last 0.
Oh yeah. So 240 divided by 10 is, well, just 24.
And now those are two normal kind of numbers that we would find in times table, so we'll do our normal method.
Yeah. And then I suppose we would need to do the same as we did with the two previous numbers.
Okay.
So we need to find the biggest times table that they both go in. So they are both in the 1 times table. That's no good. They are also both in the 2 times table, and they are also both in the 8 times table. I don't think they're in any other times table.
Okay.
So out of those I said, 8 is the largest one.
Okay.
So we divide them both by 8. So therefore, 16 divided by 8 is 2. And 24 divided by 8 is 3.
Well done. And let's try another method. So on the right, just keep halving both numbers, and what do you get?
Okay, well, we would just need to do what we did on the other one just now. So we divide them both by 8, and so
instead of dividing by 8, just divide by 2.
2. Okay, fine. 16 divided by 2 is 8, and 24 divided by 2 is 12.
Okay, same thing again.
So 8 divided by 2 is 4, and 12 divided by 2 is 6.
And again?
4 divided by 2 is 2, and 6 divided by 2 is 3.
That's it. And so whichever method you use, you'll get the same answer, the correct answer.
Okay.
Which one do you prefer?
I think I would prefer the method on the left, probably.
Okay, so you pick whichever one you prefer for any question, and you can always change. So that's ratio. What would you give yourself for that? X, a half, or a tick?
Maybe about halfway this time.
Like 3/4, like that?
Yeah.
Okay. Okay, proportion.
Okay.
So on the right, so this is just the same thing but working in reverse and using fractions.
Okay.
So this one, 1/4 are red, 3/4 are yellow. And in this one, 1/4 is also red and 3/4 is also yellow.
Yeah.
And that's because it is 2 out of 8 and 6 out of 8.
Okay.
So 1/4 is equal to 2 out of 8.
Yeah.
And 3/4 is the same as 6 out of 8. So instead of simplifying the fraction, by dividing them both, you're now just multiplying them both.
Okay.
Okay, try this one.
Okay.
And proportion just means fraction.
Okay. In a box of books, 5 are fiction and 1 is non-fiction. What proportion of the books is fiction?
And that means what fraction are fiction?
Well, in total there are 6 books,
Right.
but one of them is non-fiction.
So they want what proportion are fiction.
Yeah.
What fraction are fiction?
What fraction? Right. 6/5.
5/6.
Oh yeah, 5/6.
Yep, that's all it means.
Okay.
5/6. 5 out of every 6.
Oh yeah, okay, no, okay, I think I did it now.
Let's see. Let's try. So question 1.
Okay. In a bag of 10 coloured marbles, 7 are yellow and 3 are red. What proportion of the marbles are yellow? So there's 10 in total, but 7 of them are yellow. So it would be 7/10.
Correct. And how about question 3, the last one?
Okay, there are 36 skiers in a skiing competition. 6 skiers come from Scandinavian countries. What proportion of the skiers are from Scandinavian countries? Well, it's basically just 6/36.
And can you simplify that?
I can find a times table that they both go in, which is the biggest, which is the 6 times table.
Mm-hmm.
And so 6 divided by 6 is 1.
Mm-hmm.
And 36 divided by 6 is 6.
Well done. Got it. Okay. So this one, what proportion are black?
Okay, well then, there's 40 times in total, and 10 of them are black, so it's 10/40.
And simplify?
I want you to find the times table that they are biggest in, which is a 10 times table.
Mm-hmm.
And so 10 divided by 10 is 1. And 40 divided by 10 is 4.
Correct. And how about C?
So there's 40 tiles in total.
Mm-hmm.
And I think 20 of them are white.
1, 2, 3, 4, 5, 6, 7. I think it's 19.
19.
No, it's 20.
Okay, that's good. So it's 20 over 40. And so I'll need to find the times table that they are, well, the biggest times table they are both in, which is the 20 times table. So 20 divided by 20 is 1. And 40 divided by 20 is 20? Wait, no. It's 2.
Correct. 20 times 2 makes 40. Well done, Richard. Okay. Let's try part B.
Okay. A bag contains 64 grapes. There are 16 red grapes and 42 white grapes. What proportion are red grapes and white grapes? So, are we doing the B one first?
Yeah.
Okay, so it says there are 48 white grapes and there are 64 grapes in total. So it would be 48 over 64.
Mm-hmm. And can we simplify that?
Yeah, I will need to find a times table. The times table they are the biggest times table they are both in. They are both in the 1 times table, obviously, but that's no good. I think they're both in the 4 times table.
I think so, yeah.
It says 4 times 12 is 48.
Okay. So that's going to be 12 on top. And the other one?
Okay. And 64 divided by 4 is 16.
Okay. Can we make that even simpler?
Well, they are both in the 4 times table.
Mm-hmm.
They're also both in the 2 times table, but the 4 is larger.
Mm-hmm.
So 12 divided by 4 is 3, and 16 divided by 4 is 4.
And so our final answer?
3/4.
That's it, because those two numbers aren't in a times table.
Yeah.
Okay, let's try 3B.
Okay. There are 27 children in year 6. 12 are boys and 15 are girls. What proportion of the class are boys, but we're doing girls? So it says there's 27 children in year 6 and 15 of them are girls, so it would be 15 over 27.
Mm-hmm. Can we make that simpler?
Well, we need to find a times table they're both in. I think they're both in the 3 times table.
I think so.
Yeah. There's, 15 definitely is. There's 3 times 5 is 15. I think 27 is 2. Yeah, it is. So 15 divided by 3 is 5, and 27 divided by 3 is 9.
Well done. 5 over 9. Okay. And what is the first
one? On a farm, there are 10 hens, 30 sheep, and 60 cows. What proportion of the animals are hens, sheep, and cows? But we're doing the hens. So there are 10 hens, but it hasn't given us the total of all of them added together. So I guess the first thing we need to do is to add the 3 numbers together.
Okay.
So 10 plus 30 is 40.
Mm-hmm.
And 60 plus 40 is 100.
Oh.
So now we know there are 100 animals, and we also know that there are 10 hens, so it's 10 over 100.
Mm-hmm. Can that be simplified?
Well, the times table that they are both in are the 10 times table.
Mm-hmm.
I think that's the biggest one they're both in. So 10 divided by 10 is 1. And 100 divided by 10 is 10.
That's it. 1 over 10. And how about the last one?
Okay, so we now know that there are 100 animals in total, and 60 of them are cows. So it's 60 over 100.
Mm-hmm. And what next? Can you simplify that?
Yeah. They are both in the 10 times table, but they are also both in the 20 times table.
Right.
So I think that's the largest times table they are both in.
Mm-hmm.
So 60 divided by 20 is 30.
Similar, not 30.
Oh.
That's 60 divided by 2. 60 divided by 20? How many 20s in 60?
3.
Correct. That's all dividing means. And bottom one?
Okay. And 100 divided by 20 is 5.
Well done. So that is 3/5. So that is proportion. What would you give yourself for that? X a half or tick?
I think maybe same as last time.
Halfway between a half and a tick, is it?
Yeah.
Okay.
Sorry.
Scale factor. So if you enlarge a shape by a scale factor of 2, all the sides double.
Yes.
If you enlarge a shape by a scale factor of 3, you times all the sides by 3, and
Okay.
so on. Scale factor of 5 times every side by 5.
Okay.
How do we do this?
A rectangle measuring 4 centimeters wide and 7 centimeters long is enlarged using a scale factor of 3. What are the measurements of the enlarged rectangle? So I guess we need to divide, no, not divide, times 4 and 7 by 3.
Mm-hmm.
So 4 times 3 is 12,
Mm-hmm.
and 3 times 7 is 21.
And so what are the measurements of the enlarged rectangle?
It's 12 centimeters wide and 21 centimeters long.
Well done. 21 centimeters long. Okay, well done. 21. Let's try the... No, let's try the question. Let's try question 2.
Okay. So, a regular pentagon with equal sides of 30 centimeters is scaled so that the sides measure 30. No, not. So, is scaled so that the sides measure 3 centimeters. What scale factor was used to scale the shape? Well, it must have been, well, by the sounds of it, it must have been made smaller.
Mm-hmm.
So it's made smaller. So instead of times in, I would need to divide 30 by 3.
Right.
And so 30 divided by 3
Mm-hmm.
is 10.
And in this case, because it was made smaller, it's the other way around. So the scale factor isn't 30 divided by 3, it's 3 divided by 30. And,
Okay.
And what does that simplify to?
Simplify. Well, they are both in the 3 times table.
Mm-hmm.
They are also both in the 1 times table, but that's useless. So I guess we would divide them both by 3.
Mm-hmm.
So therefore, 3 divided by 3 is 1,
Mm-hmm.
and 30 divided by 3 is 10.
Well done. So the scale factor, instead of it from the small to the big, would be 10. From the big to the small is 1 over 10.
Yes.
And very tricky one. Let's try question 3.
Okay. A rectangle has sides of 4 centimeters and 8 centimeters. After it is enlarged, the shorter side is 10 centimeters. What is the length of the longer side? So the shorter side of the rectangle before it was enlarged must have been 4 centimeters.
Mm-hmm.
And so when the rectangle was enlarged, it went from 4 centimeters to 10 centimeters.
Mm-hmm.
And so when the 8 centimeters was enlarged.
So what would be the scale factor? 4 times something giving you 10. How would you calculate the scale factor?
Well, 10 isn't actually in the 4 times table, so
Mm-hmm.
so you would times it to the number in this times table that is the closest to 10.
Well, what I would do is, you see in the one above it, we said 30 times the scale factor gives us 3. So to calculate it, we work in reverse. The scale factor equals 3 divided by 30, 3 over 30.
Yeah.
So 4 times the scale factor gives us 10. So how would we use that to calculate the scale factor?
Well, we could do 4 divided by 10.
That would be like in the previous one if we did 30 divided by 3. For this one, what goes on top, what goes on bottom?
4 goes on top, I think.
Did 30 go on top for this one?
Oh, wait, no. No. 4 goes underneath.
Yes.
Okay. And 10 goes on top.
Yes. So if you're working in reverse, the opposite of times 4 is divide by 4.
Okay.
Okay, can we simplify that?
Mm, 10 divided by...
So just the times table they both have?
Well, they are both in the 1 times table. They are also both in the 2 times table.
Mm-hmm.
So then they're not both in the 4 times table. This 10 is not in the 4 times table. Does it goes 4, 8, 12.
Mm-hmm.
And they're also not in the 3 times table. Does it goes 3, 6, 9, 12. And so I suppose we would have to divide them both by 2.
Correct.
So 10 divided by 2 is 5.
Mm-hmm.
And 4 divided by 2 is 2.
That's it. 5 divided by 2, that means half of 5. What is half of 5?
I think it's 2.5.
Correct. So the scale factor is 2.5.
Okay.
How can we use that to get the length of the longer side in the enlargement?
Okay. Now we could... maybe we could times or divide them by 2.
So it's always the original side times by the scale factor gives you the new side. So it was 4, and then times by 2.5 it became 10. So we now want the length of the longer side.
Oh, so it's 8 times 2.5.
Correct.
Well,
And actually, let's do, there's a quick way to multiply by 8. 8 is just 2 times 2 times 2. So you can just double it 3 times. So double 2.5?
well, yeah, double 2.5 is... 5?
Yeah. Double 5?
10.
Double 10?
20.
20. And so the quick way of multiplying by 8 is to double it 3 times.
Okay.
And I believe that's the final answer, 20 centimeters.
Okay.
Yes, so that was a very, very tricky one. So you had to work in reverse to calculate the scale factor. So 4 times the scale factor gave you 10. And so we had to do 10 divided by 4 to get the scale factor. And then once we had the scale factor, 2.5, we did 8 times 2.5 to get the longer side, and it gave us 20.
Okay.
And in fact, kind of makes sense. 8 is double 4, isn't it?
Yeah.
And 20 is double 10. So they're still in proportion. Okay. Let's see. I'll leave that for a second. This one. Okay. Let's try the first one, the 2.
Okay. So it says this trapezium has sides of length A equals 2 centimeters, and B equals 3 centimeters, and C equals 4 centimeters. Complete the table to show the lengths of the sides after they are enlarged by different scale factors. Well, if it was enlarged by 5.
So the first one is a scale factor of 2,
Yeah.
and you can see they did it for you. So
Yeah.
A was 2, and so after the enlargement it became 4. How about B?
Well, B. Well, it says B is 3 centimeters, and after its enlargement it became 6.
Well done. And how about C?
And C was 4 centimeters, and when it got enlarged, it became 8.
Well done. And let's try the last one. Scale factor 1/2.
Well, A was originally 2 centimeters, and when it got enlarged by 1/2, it became 4.5 centimeters.
So it's just totally separate. So it is 2 times 1/2.
Oh, 2 times 1/2. Well, it's 2.5.
And they give you a clue. C was 4, and after scale factor 1/2 it became 2.
Okay.
So A is 2. What would that be?
1.
Yeah, you just half it. How about B?
B. Well, half of 3 is 1.5.
Well done. Well done, Richard. And so it's always just the length times by the scale factor.
Okay.
So 2 times 1/2 gives you 1, 3 times 1/2 gives you 1.5, 4 times 1/2 gives you 2.
Okay.
And let's try this.
Okay. A chocolate bar is 10 centimeters long. The family size version is 1.5 times longer. How long is the family size chocolate bar? Well, we know that a normal chocolate bar is 10 centimeters, and it also says the family size version is 1.5 times longer.
Mm-hmm.
So I think it's 10 times a half.
10 times 1.5.
Yeah.
And what do you get?
You get 5.
No. To multiply a decimal by 10, you can just move the decimal point one place.
Okay, so it's, if you move the decimal point one place, then it's 10 times 15.
So it's just 15. That's it.
Okay.
Yeah, that's it. That's the answer. And so, what would you give yourself for scale factors? X, a half, or a tick?
Maybe. Maybe a little bit lower this time.
Maybe a half?
Yeah.
Okay. So that is very, very, very tricky stuff, but you did very, very well, Richard. I'm very happy about this. Okay, I'll do our little end of lesson test. Question 2.
Simplify the ratio 100 to 75. Well, first of all, I think I would need to find the biggest times table that they both go in. They both go in the 5 times table.
You could do 5.
Yeah, I think I'll do 5. So 100 divided by 5 is 20.
Mm-hmm.
And 75 divided by 5 is 15. So it's 20 over 15.
And
No, no.
can you get simpler?
Well, I can find a times table they're both in. Since they're smaller, it's easier. They're both in the 5 times table, so I guess I can divide them both by 5 again.
Mm-hmm.
So 20 divided by 5 is 4, and 15 divided by 5 is 3.
Well done. Question 1.
Alright, so this bar is a little bit smaller, and 3 of the squares are three of the squares are shaded grey, and since there's 5 boxes, 2 of them were left white. So it's 3 to 2.
Well done. And we say, we pronounce it 3 is to 2. 3 is to 2.
Okay.
Okay, how do we do the top one?
So one coloured 5 white. Now, because what we did earlier with B, you need to colour one of the squares and then leave 5 and then colour another square.
Mm-hmm. And does it work? Do we have 5 white at the end?
Yes.
Yes. Okay. Okay, how about this one?
On a pool table, there are 7 red balls, 4 yellow balls, and 1 white ball. What is the ratio of red balls to balls that are not red? Well, 4 plus 1 is 5.
Mm-hmm.
So it would be 7 is to 5.
Well done. 7. Let me fix that. 7 is to 5. How about question 1 in this one?
Okay.
Oh no, we did that one. Question 2, sorry.
Oh yeah. So, in a class survey of 30 children, 15 children said that their favourite colour was blue. What proportion of the class chose a different colour as their favourite? Well, so 15 said their favourite colour was blue, and 15 plus 15 is 30.
Mm-hmm.
So it's 15 is to 15.
Proportion, so they want a fraction.
Oh, so it's 15 over 30.
Can you make it simpler?
I suppose I could divide them both by the largest times table they are in.
Mm-hmm.
And they're both in the 5 times table, so I guess I could divide them both by 5.
Yeah.
So 15 divided by 5 is 3. And 30 divided by 5 is 6.
Can you make that even simpler?
Well, this time they are not in the 5 times table, but they are both in the 3 times table. So I could divide them both by 3.
Mm-hmm.
So 3 divided by 3 is 1. And 6 divided by 3 is 2.
Well done. 1 over 2.5. Question B.
Okay. So like I said earlier, there are 40 tiles in total, and 10 of them are grey, so it's 10 to 40.
So this is proportion, so it's a fraction.
Oh, sorry. 10 over 40.
And simplify.
Well, they're both in the 10 times table, so I can divide them both by 10. So 10 divided by 10 is 1. And 40 divided by 10 is 4.
Well done. Part A.
Okay. So there are 64 grapes, and 16 of them are red, so it would be 16 over 64.
Mm-hmm. Can we simplify?
I think so. They are both in the 2 times table.
In fact, I think you'll be fine for that,
Okay, fine.
because
Okay.
we've done it that many times. How about part A for this?
So there's 27 children in year 6, and 12 of them are boys. So it would be 12 over 27.
Yeah, so that would be 12 over 27, and then you would just write it in its simplest form. I think you divide them both by 3.
Yeah.
How about B for this one?
Okay. There are 100 animals, and 30 of them are sheep. So it would be 30 over 100.
And let's simplify this one.
So they are both in the 10 times table.
Mm-hmm.
They're also both in the 5 times table and 2 times table and 1 times table. But the 10 is the largest one. So I could divide them both by 10. So 30 divided by 10 is 3. And 100 divided by 10 is 10.
Well done. That one is 3 over 10. What is question 1? How do we do that?
Okay. An equilateral triangle has sides of 4 centimeters. It is enlarged by a scale factor of 5. How long is each side of the enlarged triangle? So originally all of its sides were 4 centimeters, but then it was enlarged by a scale factor of 5. So it's 5 times 4. So, and 5 times 4 is 20.
Well done. 20 centimeters.
Yeah.
How about this?
Okay. This triangle has been enlarged by a scale factor of 2. What are the new measurements of the sides A, B, and C? So for the smaller grey triangle, its long sides were originally 3 centimeters, and its short side was originally 2 centimeters. But then it was enlarged by a scale factor of 2, so it would be 3 times 2 and 2 times 2.
Mm-hmm.
So 3 times 2 is 6,
Yeah.
and 2 times 2 is 4.
Well done. And let's see. I'm gonna. Okay, let's do this one.
A regular hexagon has equal sides of 3 centimeters. It is enlarged to have equal sides of 21 centimeters. What scale factor was used to enlarge the hexagon? So it has, each of its sides were 3 centimeters, and then it was enlarged to have equal sides of 21. So it's 3 times something is 21.
Mm-hmm.
And so it must have been 3 times 7. Does that equals 21?
Correct. And 21 divided by 3 gives you 7.
Yes.
And last one, this one, the 10, scale factor 10.
Okay.
And B is already done for you.
Okay, so A is 2 centimeters, so 2 times 10 is 20,
Mm-hmm.
and 4 times 10 is 40.
Well done. And that was it. So in general, ratio and proportion, what do you give yourself?
Well, proportion, I reckon, maybe what I normally go for, halfway between the half and tick.
Mm-hmm.
And for ratio, I reckon maybe let's go level the same, I reckon.
Okay. And so overall for everything, our little test at the end was a mix of everything. So how do you feel you did in that little test at the end?
I reckon halfway between a half and the tick, or maybe a tick. maybe.
Okay. Yeah, maybe something like that. I'll put it as a tick. I think you
Okay.
did great. Well done, Richard. Is there anything in particular you want to do next time, or should I pick?
Well, I was thinking this evening of doing decimals, but maybe we could do that next week.
Okay, we'll do decimals. Okay, well done, Richard. You did great. I look forward to talking again next week.
Yeah.
All right, have a good week and say. Oh, there you are, Melita. Yeah.
I just heard the lesson coming to an end, so I just thought I'd say thanks very much.
Okay.
And yeah, and we'll Richard, we'll see you again same time next week.
That's right. Yeah. All right.
Yeah.
Have a good week.
Right, thanks, and to you.
Thanks.
All right, thanks very much.
Goodbye.
See ya. Bye.
Bye.
Bye.